Hey everybody, and welcome back. In today's lesson, we're going to be looking at power of a power law and power of a product law. Now, both of them we're going to be going through in the table below. We're going to be going through every second example so that you have an opportunity to practice this. Remember, when you are practicing this, make sure you are going into the class OneNote to make sure you're doing it correctly. For the first part here, we have 2 to the power of 4 inside brackets with a power of 3 on the outside of the bracket. So we have a power to a power. In this situation, we want to write it as repeated multiplication. First thing that we need to recognize is what is our base. Well, our base is 2. And our power inside the bracket is 4. With this power on the outside of 3, what that is saying is we're multiplying 2 to the power of 4 3 times. So we have 2 to the power of 4 multiplied by 2 to the power of 4 multiplied by 2 to the power of 4. So this 3 makes it happen 3 different times. So when we wrote out the repeated multiplication, it looks like this. And writing out as a product of a factor, what we have to do is we have to take this further. So just like we did previously when we would write the repeated multiplication and expand it, we're doing that again. So we have 2 times 2 times 2 times 2 for our 2 to the power of 4 multiplied by 2 times 2 times 2 times 2 for our second 2 to the power of 4 multiplied by 2 times 2 times 2 times 2 for a third 2 to the power of 4. Now, if we were asked just to write this as a single power, what we'd be looking at is 2 as our base. Now, if we look back here, we have our exponent of 4, exponent of 4, and exponent of 4. We're adding those all together, and we get 2 to the power of 12. What you could also look at is your most expanded form, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So either way, you can look at it, and you're going to find out that you have 2 to the power of 12. The second one here I'm going to leave for you to complete on your own. And the third one, we have inside the brackets -4 to the power of 3 and a power of 2 on the outside of the brackets. So when we write this out, we have -4 in the brackets to the power of 3 multiplied by -4 inside the brackets to the power of 3, because the exponent of 2 means that you're writing this out twice. If we take this and expand it further, we have -4 multiplied by -4 multiplied by -4 times -4 multiplied by -4 multiplied by -4. If we add all those up, we should end up with -4 as our base and an exponent of 6. Fourth one here, I'm going to leave for you to do on your own, and we're going to look at power of a product law now. This time, we have a multiplication inside the brackets and an exponent involved. So we have 2 times 5 inside the brackets to the power of 3. If we are to write this as a repeated multiplication, we're going to have 2 times 5 3 times. Just like that. So we want to break this down and see how many 2's we have and how many 5's we have. We have 2 times 2 times 2 because we have a total of 1, 2, 3 2's. And we have 5 times 5 times 5 times 5 because we have 3 5's involved. Now, instead of writing it as a power, we have it as a product of a power. So what we're going to be writing down is how many times we have 2, which is going to be to the exponent of 3, multiplied by 5 to the exponent of 3 as well. So that exponent that we had here transfers on to each individual part of that multiplication. I want you to practice that below, and we're going to do the third example. So we have 4 multiplied by 2 inside the brackets to the power of 5. We have to expand this, so we have 4 times 2, and this is going to show up 5 times. So there's our third one, fourth one, and fifth one. You could either count those up, or if we know that this is a 5 right here, it means we're going to have the 4 show up 5 times. So 4 times 4 times 4 times 4 times 4 multiplied by 2 times 2 times 2 times 2 times 2. Both should show up 5 times. And if we write it as a product of a power, we're going to have 4 to the power of 5 multiplied by 2 to the power of 5. Again, I'm going to leave this last one here for you to practice. Make sure you're checking in the class OneNote to make sure you have the correct answer. The last thing on this page says to describe any patterns you see in the rows of the tables. So in the tables above, what do we notice? What pops up that's similar all the way through? Well, the number of bases is equal to the exponent. What that means is when we had it expanded all the way, the most that we could as possible, for example, this one here, we added up the total and the number of bases was equal to the exponent. So we had 5 in there and it was equal to this 5 right here. The next thing that we should have noticed is the power of a power, you multiply the exponents. When we did our first example here, we had 2 to the power of 4 inside the brackets to the power of 3. So we multiplied this together. So 4 times 3 equals 12. And that gave us our final answer of 2 to the power of 12. Sliding over to our next page here, we're looking at exponent law of a power. So what did we do on the last page? Well, to raise a power to a power, we multiply the exponents. In the example below, we have a to the power of m inside the brackets to the power of n equals a to the power of m multiplied by n. And m multiplied by n, we're talking about the exponents multiplying together. Example 1 of power of a power, write as a single power. So that's the most important thing to pay attention to. When you have something that you're multiplying a power to a power, it's going to tell you to write it as a single power. For example, a, it's -7 inside the brackets to the power of 3, and a power of 2 on the outside of the brackets. What we can do is write down our base of -7 in brackets, and we have 3 multiplied by 2, which gets us -7 as our base and 6 as our exponent. So we have -7 to the power of 6. B, I'm going to leave for you to complete. C, we have a base of 6, and we have an exponent of 2, and on the outside of the brackets of 7, so we have 2 times 7 as our exponents, so our base is 6, and our exponent becomes 14. In the last one here, I'm going to leave for you to do. Big thing, though, I want you to pay attention to is, what is our exponent on the outside? Remember, you're following multiplication rules, and when you're multiplying by a 0, think about what has to happen there. Make sure you go into the class notebook and check your answers afterwards. Now we're going to discuss power of a product law, just like we did on the table, on the second half of that table on the first page. Raise each factor of the product to the same power. So we had AB in the middle, so a multiplication in the middle, to the power of m, which meant that exponent was affecting the A and also affecting the B, so that exponent attached to each of them. In this example here of power of a product, for A, we have -7 times 5 in the brackets to the power of 2. I'm going to show you 2 different methods that we can do here. For method 1, what we're going to do is we have -7 in the bracket to the power of 2 multiplied by 5 to the power of 2. So we distributed this exponent of 2 to the first part and to the second part of that multiplication, onto the -7 and onto the -5. We take this further by evaluating, and we have -7 squared, which gets us 49. Remember, it's a positive number because there's an even number of negatives, multiplied by 25 because that's 5 squared. 49 times 25 equals 1,225. This is the way that you would do method 1. For method 2, you first look at, we have -7 multiplied by 5. So we solve for that first. -7 multiplied by 5 gives you -35. Close those brackets around it, and our exponent of -2 attaches back on where it was on the outside of the brackets. All that's left to do is evaluate. So -35 squared gives us 1,225. Notice it gets you the exact same answer. It just depends on which method you prefer doing. Both methods will be accepted, so it's a personal preference on which one you prefer to do. The first method requires an additional step, but if that extra step assists you in getting to the correct answer, then do that because it's more comfortable for you. This last part here, I'm going to have you complete on your own so that you can check that you're doing both methods correct. For power of a quotient law, which again from the last lesson was division of powers, the dividend and the divisor are both raised to the indicated exponent separately. Now what this means is we have a over b in brackets to the power of m. Now this m attaches to the top and to the bottom of this division question. So power of a quotient, we have two different setups here. We have side by side and we have on top. Both are going to be treated the same. In this situation at the top, we have 24 divided by -6 in brackets to the power of 4. We're going to do both methods to see which one you are comfortable with. So method 1, we're going to do 24 to the power of 4 divided by -6 to the power of 4. To take this further, you have to do 24 to the power of 4, which is 331,776 divided by -6 to the power of 4, which is 1,296. Our last step that we have to do is evaluate for what we have, which is the 331,776 divided by 1,296, which gives us a final answer of 256. This is method 1. In method 2, we're going to have 24 divided by -6 first. So we're addressing what's inside the brackets. Now 24 divided by -6 gives us -4, and we have an exponent of 4 on the outside, so that attaches back on. -4 to the power of 4 equals 256. So you can do either method. It's all based on your preference. Both will be marked correct. In this last question here, as earlier stated, I want you to complete this one and then check your answers in the class notebook. This will bring us to our last examples that we're going to go through, which is example 4, applying exponent laws and order of operations. This is taking everything that we've learned this unit and putting it all into one equation. It asks us to simplify and then evaluate for each expression. First thing that we need to look at is our first portion here. We have in brackets 3 squared times 3 cubed, and then on the outside of the brackets, we have to the power of 3. What this is going to get us is a multiplication in the first part. So inside the brackets, we want to address the 3 squared times 3 cubed. In our earlier lesson, we learned that if you have a multiplication of the same base to different powers, you're going to add that together. So 3 squared times 3 cubed will get us 3 to the power of 5. Closing the brackets, and we have to the power of 3, which comes over. Next part we want to address is the second part of this equation. We have in the brackets 4 to the power of 3 multiplied by 4 to the power of 2. Again, it's a multiplication, so we're looking for a product, and we're adding those exponents together because they're inside the brackets. This gets us 4 to the power of 5 in brackets, and that exponent of 2 that's on the outside comes over. Just going to get rid of this arrow. Next thing that we need to do is simplify this. So 3 to the power of 5 in brackets to the power of 3, we have it set up that we need to multiply these two exponents together. 3 comes down, and we have 5 multiplied by 3 makes 15. Subtract 4, which is our base, and we have an exponent of 5 to the power of 2, which means 5 times 2, making 10. Now we have to simplify this and evaluate. So we're taking 3 to the power of 15, and we have to figure out what that is. That will get us 14,348,907, subtract 4 to the power of 10, which will be 1,048,576. Our last thing that we need to do is evaluate and subtract these two amounts from each other, and we'll get 13,300,331. And that'll be our final answer. For B and for C, I want you to solve on your own. B will be solved the exact same way as the one above it. So put these methods that we've gone through into practice. And for C, it will be solved the exact same way, but I want to draw your attention to the exponent of 0 on the outside again. Again, when you're multiplying by a 0, remember what that produces for you. That'll bring our lesson to a close. And if you have any questions, make sure you ask me in class the next time you see me, or you can send me a message on Teams. As always, have a good day.